How's that looking? Still recording? Y'all can still see it?
Yes, sir.
Perfect. All right, well, we can go ahead and get started today. Today we are in topic 10, representing and interpreting data. We are on block 9, and in this block, our goal is to recognize misleading graphs and transform them into better representations, construct box plots, and determine outliers, make observations about the degree of visual overlap of two numerical distributions. So, what we're going to be trying to do today is figure out what makes a graph misleading and what can be done to fix a graph so that it is not misleading. So, a lot of times, the data that is put out on the internet or on TV, magazines, etc., it's misleading. And when we say it's
An opinion.
yes, it's opinionated, which is leading to biased data, meaning that they have it shown in a way that benefits themselves or their company that they're trying to, benefit. So what we're going to do is we are going to be discussing ways that graphs can be misleading. So what we're going to do is we're going to see how that is possible. So we're going to read about those possibilities right now. So this girl that's checking this magazine out, her name is Paris. She's going to be helping us today. But we're going to start with getting Miss Alora to read for us. Miss Alora, would you read this first page for us, please, ma'am?
When you look at the graph that someone else created, you must consider that the person who drew it probably had an opinion to express. Sometimes graphs can be created to show data in a misleading way. A graph can misled if the representation chosen does not tell the whole story, it is drawn incorrectly, the scales on the horizontal or vertical axis are not consistent, an outlier exists in a box plot. In this exploring, you will see examples of misleading graphs. First, for each example, try to find a similar example from newspaper or the internet.
All right. So, what was the first way that we know if something is misleading?
The representation doesn't help tell the whole story. Doesn't
All right.
include the whole population.
Good. What's the second way, Akira?
Sir?
What is the second way we know if something is misleading, a graph is misleading?
It's drawn incorrectly.
Correct. It's drawn incorrectly. What is the third way, Brendan? Oh, I don't think he knows. Help him out, Brooklyn. What's the third way?
The scales on the horizontal or vertical axis are not constant.
All right, so that means like the intervals are not the same. So if they're not the same, then that makes the data look misleading. And what was the fourth thing that was stated, Sanaya?
An outer is in a box plot.
All right, so if there's an outlier in a box plot, then that can make the data look misleading. So today we're actually going to learn how to use a modified box plot that makes a box plot less misleading, okay? So in this exploring, we're going to see examples of misleading graphs, and for each example, we're going to try to find a similar example from a newspaper or the internet. We can try to find something that looks similar to that. All right, so looking at this, if you would you go ahead and read that for us, please, Sophia?
All of it?
Yes.
Paris is upset that her parents use parental controls to limit screen time on her phone. They allow her only 100 minutes per week. She drew a box plot to convince her parents to allow her more minutes.
All right, so looking at this. says, according to this graph, what is the median number of minutes allowed per week for 13-year-olds? What do you think, Tamarian? Tamarian, what is the median? Vincent, help him out. What is the median?
The line
The line in the
box.
The line in the box. Yes. And where is the line in the box?
In the middle.
In the middle. Yeah, it's 200. That's correct. So that is our answer to question 1A. The graph shows the median is 200 minutes per week, which is the vertical line inside the box for any box plot, and that is the median. All right, let's look at our next one. According to the graph, what percent of the people surveyed are allowed more minutes per week than Paris? Devin,
75%.
explain.
So each section is 25%. So the first half of the box is 25%, the second half of the box is 25%, and then the right whisker is 25%. So add that all up and you get 75%.
Anybody need any help on that, or does that make good sense?
It made good sense.
All right, so 75% more than what she could do, because what she could do was 25% of the data, right? Perfect. So that is the next answer in our workbook. The graph shows that 75% of the people surveyed are allowed more minutes per week than Paris. 100 is the lower quartile, which indicates the lowest 25% of the data. So 75% of the data is above the lower quartile. So at this point, Paris's parents are pretty much convinced, but they remember that a box plot does not give information about how many data points are included in the graph. So why does it make a difference if you know how many points are included in the graph? Why does it make a difference? Nobody knows? Would it make a difference if a lot of people were put into this data compared to just a few people?
Yes.
Yeah, it would.
More people equals a better and more accurate
All right.
estimation.
Good. So let's see what happened and how many people she actually used. Akira, go ahead and read this for us.
Yes, sir. Box plots only show where the data lie, but not how many values are included in the data set. Why does this matter? Do you remember what you learned about samples? If the sample is not large enough, then the results may not respectively of the population. Here is the graph Paris created with the actual values included. Paris only included 4 friends and herself in the data for the plot. Because there are only 5 values in the data set, the fact that 75% are allowed more minutes per week, then Paris is not impressed to her parents. In addition to the small sample size, the sample might have favored her position because of her friend she asked. What do we call a sample that is chosen in a way that each member of the population is not equally likely to be selected? Her parents want her to make more responsive sample.
All right, so a more representative sample, right? Or representative sample. So looking at this, what we're going to do is we're going to see how just having 5 people in that sample size, we consider whenever we have a graph that is, you know, created for just our purpose of showing what we think, that's what type of graph? Go ahead, Angel. What's it called? Go ahead, Devin.
Histogram.
Well, what I'm asking is when we create a graph that represents our opinion, what is that called?
Bias.
A bias sample. That's correct. A bias sample. So, in addition to the small sample size, the sample might have favored her position. If it favors someone's position, then that means it's bias. So, this right here is our answer to our next question. So, when it says, what do we call a sample that's chosen in a way that each member of the population is not equally likely to be selected? That is considered a what?
Bias.
A bias sample. Miss Angel, we're on page 343 in our workbook. We are on our topic 10, block 9 assignment. And we are learning today about misleading graphs. So we're starting with box plots and then we're going to get into histograms. All right.
Thank you.
So looking at the next page, if you would you read this for us, Miss Alora?
Can you repeat that?
I need you to read this for us, please, ma'am.
Can you show me what specifically to read?
Everything.
Okay, yes, sir. Paris agrees to take another example. She decides to take a simple random sample of the population of 200 students at her school that are 13 years old. She puts all the names in a hat, pulls out 20 names, and asks them how many minutes of screen time per week they are allowed to on their phones. If they do not have a phone, she records 0 minutes. Here is her new box plot. What differences do you see between the new box plot and the first one that Paris made? Because you do not see the actual data, there is another way box plots can mislead. According to the new plot, where is the upper 25% of the data? The plot does not tell the exact location of the data points. There might be an outlier that the box plot is hiding.
All right. And so we're looking to see how this data compares to her new data. So now she took a random 20 people out of the 200 people that are in her school that are at her age, being 13, and she's seeing what they did. Okay. So we're going to look at her first box plot, which was right here, and we're going to compare it to the new one. So the first thing that's asked, it says, what differences do you see between the new box plot and the first one that was made? So what do you see, Braden? What's different, Braden?
The difference that I see is the median.
All right, the median is different. That's one. So in the new box plot, the median is it more or less than the first box plot?
More.
You sure?
Less.
Wait, less.
Yeah, it's less.
It's like
less.
115.
Yeah, so it's like 120-ish.
Yeah.
All right. So the median is less than the first box plot. Remember, the first box plot is the one that has the stars on it. What's something else that you notice, Erica? We're comparing this one, this was the first one, to this one. What's something that you notice is different? Help her out, Sanaya.
Can you repeat that?
Yes, what do you notice that is different? We're answering this question right here.
You talking about
Let's help her out, Devin.
The minimum is different.
All right, the minimum is different. Remember, the minimum is all the way to the left. So the minimum was originally 50, but now the minimum is 0. Sanaya, do you see anything else?
yeah.
What else do you see?
One stop at 200 and one stop at 300.
Okay, good job. That's perfect. The upper quartile was at 300 in the old box plot, and in the new box plot, it's at 220. What's something that you see that is the same? Sophia, what's something that's the same?
I forgot what it's called, but the mark at the 600.
Correct. What is that mark called, Vincent? The what?
I forgot the name of it too.
Help them out.
The maximum.
It is the maximum. The maximum. So let's go over it real quick. This is the minimum, the lower quartile, the median, because it's in the middle, the upper quartile, and the maximum. And these lines that go through here are called whiskers. All right, because you do not see the actual data, there's another way to check if box plots can mislead you. All right, so according to the new plot, where is the upper 25% of the data? Where's the upper 25% of the data? Devin's got his hand up. Go ahead, Devin.
Between the upper quartile and the maximum?
Correct. And so that would be from here to here. So that's from what number to what number?
About 250 to 600.
All right. So I'm going to say 220 to 600. And the reason I say that is because that's 250 there. But I see what you're saying. It's about. All right. Good job. So this is our answers. Is this 5A and 5B in our workbook? Looking for a yes or a no? Since y'all aren't participating, I'll find out myself. Yep, 5A and 5B. So everybody should be answering questions 5A and 5B right now. Yes, ma'am, Angel?
I was just saying, I think it is 5 a.m.
Yes, it is. All right. So it doesn't tell the exact location of the data point, so there could be an outlier that the box plot is hiding, and we're going to try to see if we can find that by finding the actual values. So could you read this, please, Brendan?
Because you do not see the actual data, there is another way box plots can mislead. If there is an outlier in the data, you may believe there are a lot of values represented by whisker when there are not. An outlier is a value outside the overall pattern of a data. Play the animation to see how to determine outliers and how to modify a box plot to better represent data with outliers. Pairs created this box plot to display the results of our survey without the original points. You may assume that 25% of the students have 400, 500, or 600 minutes a week. Compare the box plot to a dot plot of the individual.
All right. So looking at this, what we're going to do is we're going to try to figure out the difference between the box plot and the dot plot. So looking at this, what do you notice right away, Brooklyn? I think Brooklyn might be having some internet trouble. What do you notice right away, Angel? Alora? Anyone in the class?
There is a value on like in between one of the riskers.
Yeah, so we do have one at a little over 350. So somewhere in here. But 600 is a what? More than likely,
Outlier.
it's going to be an outlier. And so what we're going to do is we're going to learn how to do a modified box plot so that our data consists mainly of our cluster, and then we'll actually mark that outlier as 600. Now, we don't know if it's an outlier until we do something. And what it is that we do is we take our interquartile range and multiply it by 1.5. And then we would add that to our upper quartile. And if this number right here is more than the amount that we get, then it's considered an outlier. If it's not, then it's not. Now, if we were looking for an outlier to the left of our lower quartile, we would subtract the interquartile range times 1.5. So we're going to see how that works in just a second. So the first step in looking for an outlier is to determine the interquartile range. So we're going to use the screen time minutes provided in the table to calculate the 5-number summary and the interquartile range. Then we're going to fill in the blanks and click check to check our answers. So let's start with Vincent. Vincent, what is the minimum?
0.
Perfect. Akira, what is the lower quartile? Alora, what is the lower quartile?
50.
50. Good job. Angel, what is the median? Devin, help her out.
The median is 120.
Correct, because it's halfway between 100 and 140. What is the upper quartile, Braden?
150.
The upper quartile?
Wait, 200?
It's a little more than 200. Where would that be?
Hold on. 220.
220. Good job, because it's halfway between 200 and 240. What is the maximum, Erica? What's the largest number in that data?
Wait, I'm confused. What?
What is the largest number in the screen time minutes? What is the largest number?
I couldn't understand you because you're breaking up really bad.
Okay. I'm going to type it, but what I'm looking for is the largest number in the data. And while she's giving us the largest number in the data, who can tell us how to find the interquartile range? What do we need to do? I think Angel's got the maximum. Angel, what's the maximum?
600.
It is 600. Good job. Who in here knows how to find the interquartile range? Well, if we don't know how to find it, I'm going to try to help you. Devin, go ahead. Tell me what to do.
You would take the value of the lower quartile range and take it away from the value of the upper quartile.
Correct. So we take the upper quartile. That's an ugly cue. The upper quartile. I got to redo that. That's just bad. Ta-da. Minus the lower quartile. And that equals our interquartile range. So what is the upper quartile, class?
220.
And we need to subtract what from it?
50. Wouldn't you get 170?
Correct. It's 170. Because we have to borrow from this too. Now, it's very important to have the interquartile range for us to be able to determine if we have an outlier or not. But this is all correct, okay? So we're going to see how to use our interquartile range to find the outlier. So looking at this, if you would, go ahead and read that, Devin.
How do you decide if a value is an outlier? A value is an outlier if it falls more than 1.5 times the IQR below the lower quartile or more than 1.5 times the IQR above the upper quartile.
All right. So looking at this, that's what we're going to do. We're going to take our calculator. And he said we have to do 1.5 times the IQR. And then we have to subtract it from the lower quartile. Then we're going to do 1.5 times IQR and add it to the upper quartile. And if it's outside of that range, then it's an outlier. So let's see what happens. We need to take
When you multiply 170 times 1.5, I think you get 225.
Close. 255.
255.
And
then you would add 220.
Correct. So would 600 be considered an outlier?
No.
Is it more than 475?
Oh, yes, then it would be.
Yeah, so it's considered an outlier. If it was less than 475 or it was 475, then it would be fine. But since it's more than, it is considered an outlier. Now, it would work exactly the same if we were looking for the other side on the lower quartile. What we would do is we would take 50 and subtract 255, and that would be negative 205. So if this was, somewhere over here, and we had some data way over here, which is impossible with cell phone minutes because minutes is time times more than 0. but that's how it would work. So we're going to take a look at this. And so just like we found out that 600 is definitely considered a what?
Outlier.
An outlier. And so we're going to take this information and we're going to be able to create a modified box plot that makes our data look less misleading. Okay? And so that's actually question number 7 in your workbook, I believe. No, question number 6. So let's see what they
What
do.
page are we in our workbook?
345, 346. So if you look at this, what did they do? What did they do?
343.
What they end up doing?
They minimize the right whisker and they bring it to the highest value besides 600.
Correct. So the next value below the 475 is what they put their max as, and then they put their outlier to the side. And so is this better data compared to what she was presenting at first?
Yes.
Yes, because it's less misleading, right?
And isn't it like when the data is like more together and more compact, it's more accurate?
I would feel like yes, because I mean you're trying to pay attention to your cluster, because if your data is all spread out all over the place, then more than likely you need to get more people to sample so that you get a better sample. Or you're just in a place where nobody agrees with each other. And if that's the case, you might want to leave that area anyways.
You're in Russia.
All right, so let's look at the next page. So looking at this, you'll notice that Paris is kind of irritated. She thinks that the new box plot isn't as effective as supporting her argument because the median was at 120 minutes, which is like the middle of her class. Most of them were like, well, we're around the same time that you get to use. Well, since she wants to spend more time on the cell phone, that's not going to be real helpful to show her parents. So she decides to draw a histogram to show the screen time minutes allowed each of the 20 classmates that she polled. So when you look at it, does anything just stand out to you that looks strange?
And the box plot, we only had one. Or we had, never mind. Most of the data lies between 0 and 70.
Okay. I'm seeing something even more interesting. Nobody's caught it yet. I want you to pay close attention to your intervals.
Oh, they're not like numerical. They're like usually from 140 you'd go to 280.
All right. So
Or
like
20 to 10 actually.
yes. So they're not all 70. And so if the intervals
they're
are
not
not the same, then the data is what?
Bias.
Well, it's misleading. So yeah, it's kind of biased. I mean, the data is correct, but they're taking the data and trying to twist the graph so it makes it look like it's better than what it actually
There's more
is.
people.
And so if you look at this, That's actually the difference. Because if she would have put 70 and 70 together and had 140, like she did with the other ones, well, this would have been way up here. Does that make sense?
Yeah.
So she tried to do this to try to get over on her parents. But let's look. What I want you to try to do right now is I want you to try to answer the next question and create a histogram that would actually represent what it's supposed to. So I want you to think about what you would need to do to create the histogram so that it was shown correctly. And so remember, if you're lost, what we're noticing is that those intervals are not created the same. And so it's more than likely, what would you do to create a histogram that is not misleading? What would we need to do?
Fix the intervals.
That's it. Just fix the intervals. So the intervals need to be set at what?
The 290 can be changed to 210 and the 600 to 280.
So we just need to spread it out
Yeah.
to where they're broken in parts of 70 so that interval stays the same. So go ahead and read that for us, please, Braden. Paris did not draw the histogram correctly. The intervals were not the same width. The correct histogram shows that the value of 600 minutes was an outlier. So Paris's screen time minutes now look like they are not much different than any typical value for the data she collected. So with this, today we've learned how data can be drawn or written to be misleading, and we've learned how to fix graphs so that they're not misleading. So what have we had to do today to fix the misleading features on the graphs that we've looked at? Think about everything we've done today. What did we have to do? On the box plot, we did what?
We had to find an outlier.
Correct. So we used a modified box plot and then we showed where our outlier was. On the histogram, we had to make sure that the whats were the same.
Intervals.
The intervals. So the intervals have to be the same. The frequency has to be the same, or the data can be misleading. So what I want you to do at this time is I want you to go to your Agile Mind, and you are going to click on the topic 10, 1 through 9 guided practice and questions 21 through 23 more practice questions. And I want you to spend the remainder of class doing that. If you're not in class with us right now, you need to get this done. And if you're in someone else's class, then if you want to practice, in case you got a test coming up like we do in the next couple days, go ahead and do that.